wherever I possibly can. I actually got to hang out with Dan North back in 2004 when he was teaching BDD at ThoughtWorks. And the whole point was that he was replacing this word test. So you might not hear me use that word so much, but I'm still going to be talking about it's exactly equivalent to TDD. I'm just going to be using slightly different language, and I'm hoping that it will give you a bit of a different perspective on how we do this. Okay. So here's an example of how I do TDD or BDD at a class level. So a lot of you probably associate BDD with the end-to-end scenarios and things which cover your whole application. It actually started at a unit level. So JBehave originally was intended to replace JUnit. And the idea was that you could start your test method with word should instead of test, which is what JUnit 3.x back in the day insisted on. And nowadays we've got annotations instead, so we don't really need to have these specific BDD tools at that level, but I still do BDD. And the way I do it is I think of an example of how the class is going to behave. So I take my class and go, how should this class behave? What should it do? And that becomes my test method, should wait for events to occur. So this little class here, don't worry if you can't see the code. I'll go into it in a bit more detail. It's a class that I use for waiting for things to happen, and it's actually part of a test harness that I am also testing. So this class is called a waiter. So I start by thinking about what the class should do. And I think of an example. So given an automation element, when we cause a slow event on that element and we wait for the event, then we should be notified when the event occurs, right? That's what it should do. And I think of the context in which it should do it, that's the given. The event that should happen, that's the when, and the outcome that we want, that's the then. Okay, you'll notice there are two whens there. It is actually the thing that happens when you have an interaction of two people or time passing. There's no way to get around having two whens. It's okay to have two whens. So when I've done this, those of you who are used to doing arrange, act, assert, by the way, it's the same thing. Arranging the context, acting, performing the event, asserting the outcome, given when then, it's totally equivalent. So given an automation element, then I start filling in the code. Now you'll notice that when I do BDD, I often talk about how the examples should be concrete. The comments are abstract because the concrete example is the code. So we've got the code, we're filling it in. In this instance, I'm finding a combo box and then I'm causing a slow event. So I'm going to wait for this combo box to actually fill in with the carnivorous pet food. I'm testing a pet shop and we wait for the event. So this is the waiter waiting. It's a little bit of a complex thing. This was written some time ago before I knew Kotlin. And then we should be notified when the event occurred. Okay, really, really simple. But I fill in the code afterwards. It's just a really nice, easy way of thinking of how to do TDD. There you go. These days, by the way, end-to-end, I added this slide just because we were having a bit of a chat about it. I tend not to use the English language frameworks. I did help write one. I'm kind of a bit sorry. Back in the day when we did JBehave 1, it was very clunky and nobody actually used it, but they still had all the conversations and they still captured the conversations in that lovely rich given when then format. And I think that's been lost a little bit. So I tend to use DSLs like this and I just knock them up. There's a blog post I wrote there on how I do that. Okay, so we're all familiar with how to do this, right? This is TDD cycle. I'm just talking about it in terms of behavior, but I'm introducing new behavior. I'm writing a failing test. That's that given when then, and then of course I make the test pass and then we refactor it. And you know this, it's a TDD conference. You must have seen it a few times today. Okay, all right, but I said I was going to TDD all the things. This is where it gets interesting. I'm going to show you how those patterns apply to lots of different things and where they fail and where they fail for your code too. So we're going to TDD a person. Okay. Let's TDD a person. So people have existing behavior. They are essentially like legacy code. When you come across legacy code, before you can start doing TDD on the changes, there's usually some stuff that you want to keep around. So you want to start by refactoring it and adding tests over the stuff that already works. When you've done that refactoring and you've added those tests, then you add your failing tests for your new behavior, and then you make it pass. Okay, and this is just a nice way to deal with legacy code. I recommend Michael Feather's book, Working with Legacy Code. Really great book. He talks about seams and where to do the refactoring to start teasing this stuff apart. Statically typed languages are much easier to do this with than dynamic ones. I really love statically typed languages because I end up in these spaces as a coach all the time. Okay, so what does that mean for us when we're dealing with people? Well, refactoring and putting things under test is capturing the behavior that we want. It's amplifying that positive behavior that we want to keep. When we're writing a failing test, what we're really doing is we're describing the desired behavior and maybe giving some examples of the behavior we want. And then, of course, we change the behavior. Now, some of you might have heard of the sandwich model of feedback. Pardon my French, it's sometimes referred to as the shit sandwich. And the idea is you say something good before you say something bad that you want to change, and then you say something good again to make them feel better. Don't do that. We're going to do the sandwich the right way. And this is the 3 models of feedback. Okay, so there are 3 models that I use for giving feedback and helping people change their behavior. The first one is you want to amplify and anchor the existing behavior that you care about. If you do nothing else, do that. It's really easy. If you can't find something positive that somebody is doing, find something positive that somebody else is doing. So if you're seeing that, you know, that person never writes their tests before their code, find somebody who does and go, have you seen what this person does? I really love what this person is doing. If they write 1 test before their code, that was awesome, right? If they do something nice for you, say thank you. It's amazing how we get caught in our own heads. We forget to say thank you to people when they do good things. I've watched people demoing in a showcase for the first time, and the manager kind of goes, right, okay, well, what about this? It's like forgetting that this is the first time they've done that. That was amazing. Well done. That was fantastic, right? Make sure that the behavior you value is anchored. This also creates psychological safety. That's Google's measure. They did a Project Aristotle thing. They found they were looking for what made teams awesome. They found that psychological safety was the #1 indicator of high-performing teams. Okay. So the sandwich model done well. You amplify the positives and then you describe the outcome you want, but you don't have. You don't need to change the code yourself. People will close that gap. You don't actually need the middle of the sandwich. All right. So what's the third model? Sometimes you don't need to do this. Sometimes you can shortcut this. Sometimes you can actually just talk about the behavior you want to change. It's called radical candor. It has to come from a place of care. That means that the people you're talking to have to know what you value about them, and you have to have an idea of where you're trying to get to. You have to have done the sandwich model, well, lots already. That's how you gain enough rapport with people to be able to say, hey, here's a thing you might want to change. I will tell you that even when I do this, I remind them. I say, hey, look, I want to say something to you. Before I say it, let me please remind you, you know what I value about you, right? And you know where we're trying to get to. And I'm going to say something that's going to be difficult for you to hear, but I want you to know it's because I care about your success. And it's within the context of having already talked lots and lots about the awesome things you're doing. Here's a thing you want to change. Okay. So there's the three models that I use, and it's the same as TDD, right? Anchoring what you value, describing the behavior that you want, and then the code changes. All right. So there's a nice little model that I use for finding those examples, and it really helps, especially when I find people are new to things. So it helps me look for those positives. I think about, so it's called Dreyfus modeling. And the way I do it is I think about, first of all, how people start picking up something up. Okay, so I don't know how to drive a car yet. I started learning, and when I was learning, it was very conscious. And I had to remember the recipes, check your mirrors, do these things. And then as I became an experienced beginner, I became, we call this just enough to be dangerous, right? It starts becoming a bit intuitive, but I still can't be trusted on my own. I still do need the instructor, probably who has the brake or traveling at low speed with somebody who's watching for danger signals, etc. Right, so I can't quite go on my own yet. The next level we call competent. I've renamed this when I've used this, the practitioner. So practitioner is just because somebody is not yet successful in a particular skill, it doesn't mean they're incompetent in their whole job. So maybe somebody's learning TDD, but they're really good at DevOps and they're great at prototyping, right? So they're learning something for the first time. It doesn't make them incompetent. So I've renamed it to practitioner to avoid this implication of incompetent. As you become more knowledgeable as a practitioner, you start being able to influence people and you start collecting ways this works in different contexts. And then finally, there are the experts. I don't actually coach people towards expertise. I find that people who are knowledgeable do that naturally, usually because they found some niche where they're the only person who knows about a thing and they're being expected to provide answers about it. And so they gradually learn more and more because they feel a bit like an imposter. Everybody gets imposter syndrome, especially the experts. And then finally, they're recognized for what they do. Okay. So I'll give you a couple of examples. And I use this not just for individuals, but for whole teams and sometimes whole organizations as well. I find examples of the things that people do. So let's say somebody's adopting TDD for the first time. They can copy and modify existing tests and they can write tests after the code. And I see so many people say, that's not TDD, that's really bad. It's better than not having tests. And they're learning. It's awesome that they've started that journey of learning. Okay, so this is still a positive. They've got tests. That's great. I ran across one company where the people have been told if you're not writing them before the code, you're not doing TDD properly. So they didn't do it. They didn't even try. So amplifying the positives, it lets people try things out. Okay. I also thought I'd pick as an example how developers get work, right? So this is pretty typical of teams where they've just started picking up Scrum, they've just started doing Agile. The project manager, they've still got an Agile project manager or the product owner. Sometimes the Scrum Master is giving the work to them. So they're assigning things in the backlog, say these are going to be the things you do this sprint. And they're starting to seek feedback on their work. That's really great. They're like, yeah, is this working? Can we get this live? Can we do smaller increments? Can we ship this yet? Great. An experienced beginner who's doing TDD, they sometimes write tests before the code. Sometimes, maybe most of the time. They can do things like get TDD working from scratch. They don't need to copy other people's anymore. They know how to get TDD up and running. And the developers who are pulling work, they assign work to themselves based on their skills. We start seeing this happening. By the way, if you're in a Scrum team where you're being given the work, this is a game changer, especially if you can leave it unassigned in the backlog so that you can pick up the highest priority of work if you possibly can. It's a first step to getting real autonomy in the team. So I highly stress this. Okay, so what happens when people are practitioners? What kind of things do we see TDDers do? We see the practitioner TDDs, they're generally writing tests before the code. It's a guideline they use all the time. There are sometimes when you won't do that, and I'll get into that a bit more later. using the test to drive out the design and thinking about responsibilities, and their tests are readable and meaningful. Okay, and this is not exhaustive, by the way, I'm just picking up some examples. Developers focus on the highest priority items, and they're working on them as a team, and they're having conversations with the testers and the business representatives before they start work. It's not just documents being handed over. That's what I regard as being an independently successful Agile team. But it's not the end. This is always an ongoing journey. What do knowledgeable practitioners look like? They're teaching other people TDD. They know when to use spike and stabilize instead of TDD, and I'll talk a little bit about that too. They refactor code as a habit without even really thinking about it. And the devs that are successful, the teams that are successful, they're collaborating to the point where they've only got one or two big items. They're finishing one off where they're starting another. So they've pretty much got single piece flow working. That's magic if you can get there. But you're successful. The practitioners is perfectly successful. You don't have to get here. There's value just in getting to that previous level. You might decide that it's not the most important change, right? The team are focused on the highest priority problems. And again, this is just examples of the things I see. You might find that in your context, you're doing something different. So I pick these examples and I share them with people. I say, here are some examples of things that I do see people do along their journey. And they can look at it and go, oh, okay, I can roughly see where we are on the journey. And they feel really good because at least they've started it. I always try to make that first level, some first novice stuff, something they're already doing. Okay, so they have some confidence about what they're already able to do. And there we go. I don't coach experts. They'll get them there themselves. So there we go. Novice, experienced, beginner, practitioners, knowledgeable practitioners, and experts. It's always phrased positively. If you're thinking, you're not writing your test before your code yet, flip it and move it down a level, move it to the next level. Okay, so practitioners write their tests before their code. So you're always thinking, okay, I can see that person, they've got some of their journey to go. What's the next stage in that journey? How can I describe this in a way that's positive? And that's your two slices of the bread. All right, there's a problem. People are weird. They don't always do what you think they're going to do. They might choose not to listen to your feedback. They might go off and do some tangential thing you didn't think of. There might be side effects as a result of them adopting a behavior that you want them to. Guess what? Your code is weird too. And I'm going to show you why. And I'm going to show you what to do about it. To do that, I'm going to use the Keogh model. It's pronounced like Kevin with an N in it. It really is the hardest thing about that model is the pronunciation. Oh, sorry, it skipped on. Okay, so this is going to be the shortest introduction in the world ever. There are 4 domains in Keogh plus 1 in the middle, disorder, where we don't know which applies. It's a framework for making sense of different situations depending on how predictable or unpredictable things are. So clear problems, you can categorize them. It's one of those. Dull, I know what to do, right? Complicated problems require expertise. They've still got a predictable outcome, so you can close the gap between what you have and what you want. Analysis works. Chaos is a domain we don't really like. It's transient. It resolves itself really quickly, not necessarily in your favor. It's urgent. It's urgent production bugs is usually what we encounter. The clear stuff we usually encounter is things like login. It's just boring. And the complicated stuff is often things where you need an expert. The example I've used before is GPS libraries, right? There's a function which calculates the distance from 2 GPS coordinates. And it's not changing, but I don't know how it works. I just copy it, or I go find an expert who can explain to me how it works. But then we have complexity. And the complexity thinkers use those words complex and complicated in 2 different ways. So complexity thinkers, when we're in complexity, stuff emerges. It's not like chaos. We've got time to try things out. But the outcome isn't predictable. You can tell how you got there in retrospect. So we have to do what's called probe, which means to try something out that's safe to fail. In software, that means a spike or a prototype. It means we're not necessarily sure what the outcome's going to be. If you're not sure what the outcome's going to be, you can't write the assertions. You might not know all the scenarios. You might not be able to write all the tests for a class if you're not quite sure how that class should behave, what it should be doing. It's going to emerge. So how do you tell what kind of thing you're looking at? There's a little scale that I use, which I find really helps me. I ask, who in the world's ever done this before? 5, nobody in the world's ever done this before. It's totally new, might not work at all. 4, somebody's done it, but not in our organisation. So we have no way of knowing what they discovered when they did it. We don't know what systems they had in place that let them do it. 3, somebody in the organisation's done it before, or we have access to expertise a different way. We can learn it from a book, learn it from YouTube. 2, someone in the team's done it before. 1, we all know how to do it. Okay, and this is just a guideline. The thing is that when we're doing software development, there's always some aspect of it that's new. We're providing new capabilities to the business, new behaviour that they never had before, new things that they're going to be able to do that they couldn't, or that a system's going to be able to do, or a customer's going to be able to do, a staff member is going to be able to do. Or it might be doing it in a new context. It works in Chinese, or it might be with a new quality, same, only faster. But there's always something new that's driving what we're doing. There's always a 5 or 4. Those 5 or 4s are where the value is, but they're also where the discoveries are. They're unknown unknowns. They're risky. We don't know what the risk is because we've never done it before. We have no experience of the risk. But we know that the risk is in those 5s and 4s. You won't find it in a risk matrix written down, because that only applies to stuff you've experienced. It's unknown unknowns, but we're going to make those discoveries. We're going to learn by doing. We need to spike, and then once we understand the problem and it's moved into that complicated space, then we can refactor it. Or if you don't have people like me that really, really love refactoring for fun, rewrite it with your tests up front. So there's a couple of different ways I use this. Complex, spike and stabilize, do BDD around the predictable bits. Sorry, my slide deck is misbehaving. We always discover things when we do it for the first time. Complicated stuff, that's where you want to learn from the experts. Perfect place to do BDD, TDD, document what you're learning by writing tests. Tests are living documentation, right? Those lovely living examples. For the clear stuff, if you're doing BDD, I find it enough to name the scenarios and don't write them out. But ideally, you're using libraries and off-the-shelf stuff anyway. As you get down into the clearer stuff, into the more obvious stuff, Dan North's got a great pattern he calls ginger cake. It's exactly like the chocolate cake, only with ginger. You know, wrap some examples around what ginger is like. Don't worry too much about the rest of the cake because it's boring. We've done it before. Okay, so focusing your efforts where the risk really is. If you're in chaos, then you probably aren't even at this conference because you're busy fixing all those urgent production bugs. Don't be going through that 5, 4, 3, 2, 1. Just, you know, get your war room together. People drill for chaos, by the way. That's what they do in chaos. So there you go. Different ways to use to approach TDD depending on how predictable or unpredictable things are. Okay, so the one thing I haven't really talked about is refactoring. What do we get from refactoring code? We get things like the lovely single responsibility principle. We divide things up, we extract methods out and extract classes out. We get good design, we can trust what the code does. The code emerges, it always needs cleaning up, so be forgiving when you find messy code. Be forgiving of yourself when you find it 3 months later and you're cursing the person who wrote it. Aim for better, not perfect. At some point, refactoring that code will not be the most important thing to do. Okay, so what do we do when we're refactoring people? What does it even mean to refactor a person or a team or an organization? It means we're playing to our strengths. We're playing to our differentiators. We're playing to the things that make us unique as people or as an organization. We're playing to the things the team does well. We're letting others help us with the stuff that we don't do well. Maybe we call on a DevOps expert from another team and ask, can you please come and help us with this? Maybe we get somebody else to teach us TDD. Or maybe we actually just go do all the really spiky and prototyping stuff and let somebody else clean up because they love that and they're really good at it. Simon Wardley, when he does Wardley mapping, talks about pioneers, settlers and town planners, your hacky, spiky, prototyping people like me who love refactoring and getting things stable, and then the people who have the big picture, the architects. People change. They always make mistakes. They're always trying new things for the first time. There's a saying, we get promoted to the level of our incompetence, the Peter principle, but it's because we've never done that role before. So of course we're not practitioners in that role. So be forgiving when you see that, be kind, call out the positives, give them a place to anchor what they do well. There's a reason that promotion happened. Aim for better, not perfect. There is an exception to this. Somebody once asked me, what would you do? How would you apply these principles to dismantling nuclear power stations? That was his job. I said, I don't know. If we have an explosion in the code base, we just roll it back. So unless it isn't safe to fail. If it's not safe to fail, you probably want to be testing it very rigorously indeed. And make sure you prototype it thoroughly. Okay, so that's it. I'm just going to summarize what I've said in this session. First of all, amplify the positives. Anchor the code that's valuable when you're working with legacy systems. Eventually, all systems do become legacy. Simon Wardley says they always move to the right, but they also become more complex over time as well. In complexity, tests and descriptions of behavior are just examples of what might happen. And you want to spike and stabilize those examples. Don't bite off too many of them when you're spiking. Just 1 or 2 is probably enough. I like to have about 7 scenarios or 7 tests in my head before I move on to the next thing. Change code, but help people change themselves. You don't need to address the problem. Describe where you want to get to. Okay, describe what the outcome that you're after looks like. Keep it positive. Unless you've got that rapport and you're saving a lot of time, saving a lot of pain by introducing that radical candor. Amplify your own positives too. We are so cruel to ourselves. We feel like failures so much of the time. We focus on the things we do wrong, on the things we got wrong, the things we don't know how to do yet. Think about what you do know how to do. Think about where you've already come in your journey. Remind yourself of that. Write it down. Stick it on a post-it on your monitor. Give yourself the psychological safety to try out the new stuff. And then your behavior will change for better too. That's it. Thank you very much.
Thank you, Liz.